Hi, we want to do some modeling with sinusoidal data and then also go through the apps worksheet for your exam so you can study with that. Okay, so what I'm going to do is I'm going to model some height off the ground on the extreme swing at Valley Fair in Minnesota. We want to model this with the following data here. So I'm on the swing. There you go. Ooh, I get a little sick watching this. And so I measure my height off the ground. Oh, I get a little nauseous watching that. Okay, so here's my height off the ground. 125 feet is its maximum height. I start at 18 seconds because it starts off slower and then gets to its maximum at that value. And then at 21 seconds, we're back down near the ground, 3 feet above the ground, and then so on. So there's my data and my height off the ground. So if we want to model this with a sinusoidal equation, what we should do, first of all, is find out our maxes and mins, because the maxes and mins will help us find A and D for either one of my equations that if I want to use the sine or the cosine functions for. So if I identify my maxes and mins, let's assume that this is the max and then this is the min. So my maximum is going to be 125 and my minimum is 3. Now when I do this, my A value is going to be 1/2 max minus the min. So when I do this, this is 1/2, 125 minus 3, half of 122. Half of 122 is 61. And so if we do that, we can also find our D value. Our D value is the average of the max and min. So if I do that, that would be 1/2, and then I add those two together, 128. And I'm going to get 1/2 of 128, which would be, I did that wrong, 64. So it's just 64. And then the next thing that you look for the data is make sure that you look for one complete cycle. So I want to know the period. You can go from crest to crest, which means the top maximum value to the maximum value. Or if you do the middle values, you just got to be careful that you complete the full cycle. But regardless here, top to top is this distance here. So I'm going to go from 18 to 24. So it takes 6 seconds to complete a cycle for my height off the ground. And so when we swing back and forth, it takes 6 seconds. And then if I look at that, this is not a value that I use in my equation. The value I need in my equation is the b. And so I go 2 pi divided by p. So that would be 2 pi divided by 6. Sometimes I ask you to leave it like this, but this one you can change to pi over 3. Now that just leaves me my phase shift. Now my phase shift is how long does it take before I hit this maximum value if it's the cosine, or if I hit a middle value if it's my sine. Now if you look at this data, this is the maximum and this is the minimum. I don't have a middle piece of data for my sine. I could average these two because it'd be right halfway in between, except for that would be a negative sign since my data is going down. If my data is going up, I could write an equation for the sine if I average these two, which would be 22.5. So if I write an equation for the sine, my C value would be 22.5. And then for the cosine, I can just take a maximum value, which is the 125, so I can do C is equal to 18. Could I use C is equal to 24? Yes, I could. Could I use C equal to 30? Yes, I could. I could use either one of those because of the repeating nature of the curve. I can use those different C values. Now let's go ahead and write these equations. If I use this cosine graph, well, all I do is y is equal to, I have my A value, 61. Then I have the cosine. Then my B value, where's my B value? There it is right there. It's going to be pi over 3. If you want to decimalize that, you can, but it just tells me more if you leave it either pi over 3 or 2 pi over 3. Then my x, I leave as my x. That's my height. I'm sorry, that's my time. And then minus my C value. My C value would be 22.5 seconds. Oh, that's the sine. For this one is 18. And then I go plus my D, which is plus 64. There's no half there. Okay, so that's your equation of the sinusoidal for my height off the ground at a certain time. This you could maybe use T, and this you could use H. That would be more specific for what we're doing. Amplitude is 61. That means that I go from 3 to 125. If I double that, that's that distance. And then this right here, 64, is my vertical shift up. That's the halfway of the point of this graph. Okay? Now if I do the sine curve, y equals, a lot of the same values occur, pi over 3, x minus, that's the only value that's going to change is my c value there, plus 64. We said that this was 22.5 because I'm increasing the data here, and so my shift is somewhere in between those, halfway in between. So then that would be 22.5. So those would be both of my equations. Now from here, I might ask you, how far off the ground are you at t equal to 2 seconds? I'm sorry, let's get in the range there. 22 seconds. And so what I do is I just take that t equal to 22, I plug it in here, and I get a value. Make sure you show setup. In other words, show me that you would write this because you're going to use your calculator. So go ahead and plug it in and then get me the answer. Okay? And then you could use the same thing over here. The other thing I might ask is, when is my height? When am I 100 feet off the ground? 100 feet is the actual height of the tower here, but you go 25 feet over the top of the tower. So I might ask, when am I at the exact height of the top of the tower? And so with this, you would set up 100 is equal to 61 cosine pi over 3, and then this would be x minus your 18 plus 64. Okay, so here's my equation. I press enter. Oh, I get a little bit of it. Notice that the minimum now is at this time 3. My window is terrible, so I want to change my window. So I do my window settings. And what do I need to make my maximum? Well, what is my maximum value? If you remember, it's 125, and so I can go a little bit more than that, maybe 150, just to pad it so I get a good idea of what this looks like. And I did go from 18 to 30 because that's what I'm doing. Now if you look at this is my height off the ground. So over 6 seconds, I go from being really high off the ground to being really high off the ground again. And so this is the cyclical pattern that we want to do. Now to see when I'm 100 feet off the ground, I can go Control G and just type in 100. There we go. And so now I have these two graphs, and then I just go Menu, Analyze Graph, and I want to do the intersection. And if I don't like my decimal places there, I go plus, hover over it, and do a plus sign. That gives me more decimal places. Now if you notice, this is one time I'm 100 feet off the ground. I can find all of these. This one and this one differ by 6 seconds. This one and this one differ by 6 seconds. Why? I hope you know that answer. All right, let's go through a couple things on the apps worksheet, and you can go ahead and figure some of those things out. You might have to find the rest of those. I'm not going to find the rest of those for you.